All right, let's try to finish up whatever this is, 8-1. And I got to change this. Just forget. So the last thing we did was example 1. So there's a theorem after example 1 that's it's kind of similar to what we talked about, but just slightly different. So I'm going to copy and paste these two circles. I don't know if I've used this word before. Have I talked about congruent circles? I bet you anything. Well, not anything, because you never know. But I would guess that if I said these two circles were congruent to each other, what do you think that would mean? Exactly right. The radius would be equal to each other. Okay, so if this circle has, I'm just going to draw it like that. So if these, oops, it's not what I wanted. So whatever the radius of this is, if the radius of this circle was exactly the same, tell you what, let's just see if it is. I'm just going to Control C, Control V. Watch, if I put it right on top. Yep, look at that. Same exact radius. Would you agree? All right, so if these, keep saying triangles, stop. These are circles. If these two circles were congruent to each other, that means that both of the radii would be what? Equal to each other, okay? Equal to each other in length. So if this was 5, this had a radius of 5, and this had a radius of 5, what's true about those circles? They are congruent. 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 We don't say equal, they're congruent. All right, so let's do this. Let's draw like this, and I'm actually going to copy and paste this one so it's exactly the same. And put that right there. All right, let's label these. Call this A and Z and X and Q and R. Use some weird letters. I'll tell you what, let me do something here. I should have recognized that. Let's do that. Does that mean I changed the length of the radius or anything? No, I just turned it a little bit, no big deal. Okay? And this is B and Y and U. BYU. Do you know BYU? Brigham Young University. They have a really good photography video series from BYU. It's like perfect. If you want to be a school photographer and shoot games and stuff like I do, man, it's like absolutely everything you ever needed to know about shooting that kind of stuff. They have a really good program. So I've watched a lot of BYU photography videos. They go to games, basketball games, they go to football games and stuff like that, and they show you the pictures that they took. They show you how they took them, all this other kind of stuff. It's really, really good stuff. Anyway, I just thought I'd throw that in there since I saw BYU right there. All right, here's the deal. Let me read the theorem. I'm not going to write it down because it's pretty lengthy, but I'll write down all the stuff that's true about it. All right, so it says incongruent circles. Well, do we have congruent circles? Yeah, you saw me copy and paste, right? And we saw the radius was the same on both of them. So yeah, we do have congruent circles right now. It says, or in the same circle. So I could have one big circle and have like this picture over here and these lines over here on the same exact circle. Everybody with me on that? So it says incongruent circles or in the same circle. So it could be one big circle with all that stuff inside one big circle. All right. It says two chords are congruent. Which ones are the chords here? What is the chord on this first circle right there? Give me letters. It'd be line segment what? QR. That would be the chord. Is AZ a chord? No, AZ is the what? The radius, okay? What's the chord over here? PN. It says two chords are congruent if and only if, we'll talk about that in a second, so if they are equidistant from the centers. So this chord right here, this QR, okay, if it's equidistant to the center as this chord PN is, then those triangles would be congruent to each other, okay, which means they would have the same what? radius, right? So what does that mean, equidistant? We've talked about that before. Let's review just briefly. What if I had, let me think, equidistance. What was I going to do? I had an idea, and then I thought, no, that's not what this is talking about. Let's just do... So dumb. I don't know. I don't know where I was going with that. Let's just say this. Okay, let me read it again. In congruent circles, which we have, it says two chords are congruent if they are equidistant from the centers. So what does it mean to be equidistant from the center? Well, what is the distance? Okay, this is where I was going with this. Now I remember, okay, the distance, not the equidistant part, but the actual distance. Oops. So, what is the distance? Oh, I hit those words and it changed my writing, so I got to go back to where it was before. Okay, so what if I had a point right there? This is where I was getting. I knew I was going somewhere with this. What is the distance from this point to this line right here, this line segment? Is it from there to there? Is it from there to there? Say it. Say the word. Very good. It's the altitude. Remember that? And what is the altitude? The altitude is from a point what? Perpendicular to that line segment. Everybody understand that? So that's the distance from the point to the line. All right? So it's the same thing here. What is the distance from the center to the chord? Give me in letters. Give it to me. What is the distance from the center, which is point A, to the chord QR? Well, is it the whole radius? Give me letters. I got enough letters here. You can just tell me what it is. QR is the chord itself. What's the distance? Listen, here's the point. Pretend that's the center, okay? Pretend this is QR right here, okay? What's the distance? That's the distance. It's from A to X. Very good. Okay, so AX is the distance. Everybody see that? Okay, so again, I'm going to read the theorem again. I probably should have written it down, but it is a little lengthy. In congruent circles, two chords are congruent. So QR must be congruent to PN if they are the same distance to the center. All right, so if I knew that AX and what? BY were equal to each other, then what would be true about QR and PN? Then they're congruent. Now, it also has to do this. Remember we said the distance got to be the perpendicular distance. So what must be true about this? That's got to be perpendicular. That's right. Okay. All right. Everybody see that? All right. So if this was a right angle, the distance from A to X, all right, that little distance right there, and the distance from B to Y, that little distance right there, would be equal to each other. And it works both ways. So let's read it again. It says, in congruent circles, two chords are congruent. So QR would be congruent to what? PN, just put it right there, if what was true? Right, if AX was equal to what? BY, okay? Everybody see that? Yeah. So if I knew this, if I knew that this little chord, it's not even a chord, this little segment, okay, from the center perpendicular to the chord, that little segment right there. So if I knew that AX and BY were equal to each other, what does that tell me about QR and PN? That they're equal to each other, exactly right. Everybody see it? All right, so if I know from the center, I remember just doing this not too long ago with my honors class, okay? And I had forgotten all about this theorem, and we were doing some problem. They asked me to do a problem. I'm like, okay, I know that QR and PN would be equal to each other, but I'm not sure exactly why. And I had to go flip through the book, and I found this theorem. I'm like, oh yeah, it's that theorem right there. And we must not have talked about it very much because it just didn't stick in my head. All right, so So this is something that you will see later on. It's probably on a test because I think we were reviewing for a test. And somebody was saying, well, why is this equal to this? And I was like, you know what? I know they're equal, but I don't know why they're equal. And then I had to flip back and I found this theorem. Okay? So here it is right here. So if that little piece right here and this little piece right here, the distance from the center to the chord, if they're equal, then the two chords are equal. Well, vice versa. The converse is also true. All right? So what if I knew that QR, if QR was equal to what? PN. So what if I didn't know about this little segment here and this little segment here? But I did know that QR and PN were equal to each other. Then what do you think I could say about AX and BY? Then they're going to be equal to each other. Okay? Everybody see that? So if QR, the two chords, if they're equal to each other, then the distance from the center to the chord are going to be equal to each other. Then AX is going to equal BY. You see how I just switched I should have written it like this. That was kind of dumb, wasn't it? Oh, shoot. Sorry. Let's try this again. See if I can grab this thing. There we go. All right. So I should have written it. Get that stupid thing out of the way. All right. So here's how I should have written it. If AX is equal to BY, then, see, that's the distance between the center and the chord. If those two distances are equal to each other, then the chords are equal to each other. You could flip it and say what? If the chords are equal to each other, then guess what? The distance from the center to the chord is going to be equal to each other, right? So if I knew that QR was equal to PN, then that means that what? AX has got to equal BY. I really confused stuff out of you, didn't I? Sorry, I just got a little mixed up. This is not one of those theorems where apparently I don't remember it very well because in my honors class I didn't remember it. So it's probably good that I go over it again. Okay. Right, because remember I said this is I'm finishing up that lesson, right? Remember I said some of the problems that you were going to do last night you probably wouldn't be able to do? You probably have some problems that are like this, okay? All right? So you should be able to do the problems that have something to do with that today. All right, let me go on. Let's do an example. Examples are always better, aren't they? Right? Throw some real numbers in there, you're good to go. Oops, I don't want that. Let's do another circle. Let's do two circles. I'm going to copy and paste it. So if I copy and paste them, what's true about these two circles? They're congruent to each other. All right. And let me put a center here, and let me put a center here. All right. And let's put a chord here. I'm going to copy and paste that chord. And yeah, there we go. All right, all I did was rotate it. I didn't change the length of it. And I'm going to put that chord right here. Everybody with me? All right, so now what I'm going to do is I'm going to find the distance from the center to that chord. So it has to be what? Is that the distance? Is that the distance to there? No, where's the distance? Perpendicular, not straight. Okay, perpendicular. Okay, so that's the distance. And what's the distance from the center to this chord? That's also perpendicular. I'm just eyeballing the perpendicular because I don't have a way to actually make it 100%. I will, yeah. All right, so that's the distance to the chord. That's the distance to the chord. Everybody got it? So I don't know anything about it. I don't know if those two distances are the same just yet, but you know something's going to be equal, right? So here's what they do. They say, oh, let's put some letters in here. A, B, C, D. Oh, they take that all the way through is what they do here. So watch. They take it all the way through, and they do the same thing here. They take this one all the way through. And what do they call that thing in the middle? E. How about that? And they call this one, that's G. That's H. This is F. This is I. And this is J. All right, here we go. Finally. Here's what they ask you to do. They ask you to find AB and GF if CD equals HI and CE equals HJ. Man, they give you a lot of information, but now they also tell you some other stuff. They kind of tell you AB. They don't tell you exactly because that's what they want to find, but they kind of tell you AB, which is 5y minus 3, and they kind of tell you GF, and that's 2y plus 9. All right, they give you a lot. They give you more than you really need probably, but so I want to find AB and GF. I want to find those two chords, the length of those two chords. That's what I'm trying to find, okay? And it says that CD, see that whole entire radius, is equal to HI. What does that basically tell us? When they tell us the radius of both of them are the same, what does that mean that's true about the two circles? Yeah, let's use a better word, but not equal. They're congruent to each other. The circles are congruent to each other, okay? I know what you meant, but we talk about shapes being congruent and not equal to each other. Line segments can be equal to each other. Angles can be equal to each other. But the what I say? The shapes, yeah, the shapes are congruent to each other. All right. So we know all that's true. And then, so if CD, if that is equal to HI, they're congruent circles, right? Yeah. And then it also says that CE, this little bit right there, they tell you that CE equals HJ. We just went over that, didn't we? So if the distance, right, from C to E is the same as the distance from H to J, what is true about those two chords? What's true about AB and GF? They're congruent to each other. They're equal to each other, all right? So it's what we've been doing all year long, isn't it? Just setting things equal to each other, solving for X, solving for Y, plugging it back in, right? We've done that a million times. Well, maybe not a million, but it seems like it. So what are we going to do? Set those two equal to each other. So I've got 5y minus 3 equals what? 2y plus 9. And now it's a piece of cake. Super easy. All right? Subtract 2y from both sides. What do you get? 3y. Add a 3 to both sides. You get 12. Divide by 3. Y is 4. But that's not what they ask for. I mean, you need to know it. But what do they ask for? The length of AB and GF. So if I find one, what's the other one going to be? The same exact thing. Okay? Everybody got that? So let's, I don't know, which one do you want to put it in? Just AB? What did we say it was? Y is what? 4? Okay. I'll put it there. Sorry, remember. So you just plug it in. So it's 5 times what? 4 minus 3. That's 20. Minus 3 is 17. So AB is equal to 17. Without doing any math whatsoever, now I should be able to find GF. What's GF equal to? It's equal to 17 as well. Pretty easy, isn't it? Yeah. Not bad at all. All right, let's do another one. And then we'll be done for today. I was thinking about starting the next lesson, but what's this, 2:15? Yep. Yeah, so we don't have time anyway. So let's just do this. And then I'll let you finish up that homework. Yeah, this is another example. This is example 3. It's that prom? What video? What video are you talking about? Oh, right. I forgot about that. Yeah, we might. Maybe we'll go over this homework and then I'll show you the video. Anybody going to prom in here? Nobody? Nobody else is?
Matthew?
All right.
No, he does not, bro.
Don't ever play with Matthew.
Do not lie.
Yeah, don't play with Stop.
Oops. Oh, wait a minute. I copied the wrong one. I got to copy the radius. Actually, I just do this. Oh, I'm so dumb. All right, you still with me? We're not done yet. Now I want to copy this. I want to make this so it looks perpendicular. All right. This doesn't have to be exact, but it's pretty close. I think it's pretty close. All right, let's put a bunch of letters in here. This is A, this is B, this is D. This intersection is H. The center is C for center, I guess. This is G, F, and E. And one more is J. And what do you think? This is probably the distance, isn't it? So what do you think must be true? Right angles right there. Okay, so that's everything they give you. Everybody with me? Are you drawing this thing? Good. Let me scooch it over so I have some room to write. Here's what it says. This is example 3 in the book, and it says find CH and HB if AD equals GE equals 10. And it's centimeters. We'll throw that in at the end, okay? All right, well, let's take a look. Remember what I said earlier about if in two congruent triangles or in the same triangle? I said triangle again, stop me. What am I trying to say? Circles, thank you. You gotta stop me. I say triangles all the time. So in congruent what? Circles or in the same circle, right? This is a situation where we're in the same circle. I got two different situations here, but I'm in the same circle. It's not two different circles. Everybody got that?
Yeah.
All right. So it still works though. The distance from here to here has got to be equal to the distance from here to here, which means AD and GE should be equal to each other. And they tell you right off the bat, didn't they? All right. They told you that it was equal, and you kind of figured that it would be. So think about this. This is the converse of the theorem that we just learned. So if the chords are equal, then the what? It's not the whole radius. Well, the radius would be because they would have the same radius. But the distance from the center to the chord, okay? From the center, the distance from the center to the chords are the same. Okay? Everybody got that? So if I know that AD and GE are equal to each other, I must know that this and this are equal. That's what the theorem says. Right there, that in a nutshell is what the theorem tells us. If the two chords are equal, the distance from the center to the chord is equal. Everybody good?
Yeah.
Okay. And they actually tell you what it is. What is, or they tell you AD. We got to find the CH and the CJ, or the HB. Where'd they get HB? Oh, okay. Because you're going to find the radius, and then you'll find this and the radius, and then you take it away to find what's left over. Okay. But what do they tell you right now? AD is 10. Now, what else did we know? We learned something the other day. It was yesterday. We learned something else about the radius and the chord. If it's perpendicular, what does it do? It bisects it. That's right. So I'll tell you what. Let's use different colors at this point, because I'm going to have a lot of tick marks. Okay, so I'm just going to go blue. We'll go blue tick mark, white tick mark, then another tick mark. Okay, everybody with me on that? So if these two chords are equal and this one bisects it, what must be true about GJ and JE? That they're going to be the same, aren't they? So all the blue are going to be the same. Now, they're not just the same. I actually know what they are now. I actually know the measurement of it. Remember, AD was 10. So what's this little bit? Yeah, that's 5. What's this little bit? What's this little bit? And there we go. Everybody good? That's going to be helpful. I'll tell you what. I'm going to move it down here just because I'm going to use that in a second. All right, so far so good. So what do we do? Let me see something here. Yeah. So what do I want to find? I want to find CH, correct? Or JC would be the same thing, wouldn't it? HC and JC would be exactly the same. All right. For some reason, I did the JC one. All right. But watch this. you may not have thought about doing this, but what if you did that? And did they tell you something else? Oh, you know what? I forgot to tell you. Has anybody got the book in front of them? Anybody have it? The book? You got the book in front of you. Open up to example 3. Did they tell you CE? Did they tell you something is 13? But on the picture itself, did they tell you what CE is?
Yeah, 13.
Okay, and they put a dotted line there? Okay. All right. That's what I wasn't sure about. So they do tell you that. All right? Because that's important. If they didn't tell you that, you wouldn't be able to do this, okay? Everybody watching now? I'll tell you what, let's go to another color now. All right, everybody look here. Everybody's paying attention, right? Looks like we're off the rails a little bit. Everybody look up here. If I draw this, I've got a right triangle, don't I? And again, what am I trying to find? I'm trying to find CH, which is the same thing as what? CJ. All right? So instead of CH, let's just call it CJ. And I can find that really without doing any math. Now, you could do some math, but you don't have to because we learn some Pythagorean triples. Do you remember those? What was the smallest, easiest Pythagorean triple? 3, 4, 5. That's right. What was the one right after that we learned? You remember? 5. No, you had 5, 12, 13. Right. Okay. Now, I'm going to show you why that's so important because look at this. I have a right triangle here, don't I? I got one leg is 5. The hypotenuse is 12. So what is the other leg going to be? It's going to be 12. If you remembered 5, 12, 13. If you didn't remember it, how could you find it? You could find it if you didn't remember 5, 12 Pythagorean theorem. Let's just do it real quick. I got a couple minutes, and this is the last thing we're doing anyway. So let's do it. So what is it? 5 squared plus, let's just call it x. Is that all right? X squared equals what? 13 squared? Yeah? 25. 169. Subtract 25. Right? X squared is what? 144. Oops. My pen is not writing as fast as I'm writing. Take the square root. What's x? 12. There you go. But you could have saved yourself all that work just realizing that it's a 5, 12, 13 triangle. So aren't you glad you learned the Pythagorean triples? Okay. All right. So that would be 12. That's actually one of our answers, isn't it? Because if CJ is 12, what else? CH is going to be 12 as well. Everybody got it? That's right. The whole radius, they tell you the whole radius, don't they? Right? From there to there is 13. So look, this whole thing from there to there is 13. So how do I find HB, this little bit right there? Just subtract. 13 minus 12 is 1. And that's how you do it. Everybody got that? Write it down if you don't. Now we've officially finished. So I'll keep that there just in case you need it. So 10 to 24. You might have already had some of the first ones done, right, from yesterday. But if you didn't, now's your chance to do it. All right, I'll collect that tomorrow. Yes, tomorrow? Yeah, you're going to be here tomorrow, right? Okay. So that's what it's going to be. And it's going to be, just call it section 8-1. Well, turn it into me earlier in the day. All right, listen to me. Turn it in earlier in the day before you leave for your game. Okay? All right, everybody got it? It's not A or B. We're just going to call it section 8-1, 10 to 24, and that will be it. All right.